Welcome to our channel. Today we are going to discuss about time series forecasting using deep learning. So we are going to see the explanation of the topic named time series forecasting using deep learning. So in deep learning there are many architectures. In that, for forecasting, the LSTM network is the best architecture to develop the programming. So LSTM network is nothing but a long short-term memory network. Okay, so our objective is we have to forecast the time series. So for that, initially you have to load the sequence input data. So for that, we are using the standard dataset named chickenpox dataset. Okay, so here we are calling the chickenpox dataset. Then we are converting all the data into a single column. So here you can see all the datasets, we are converting it into a single column. So I will just run this program so that you can able to understand it parallelly. So here you will be getting three images. The first image is nothing but the input data. So here you can see the plot of the input data. So here the X label is nothing but the month and Y label indicates the cases. The title monthly cases of chickenpox. So then the second image is nothing but you will be getting the iterations. So you will be able to see the LSTM neural network. You can visualize a neural network here. Okay, so I will explain the code. Here you can see data equal to, you are going to arrange all the data value in the form of a single column, then plot that value. X label denotes the month and Y label denotes the cases. The title is nothing but monthly cases of chickenpox. So now we are going to find the training data and the testing data. So we are going to extract the values from this data. Okay. So here, whenever you split the data, the training data set should be more when compared to the testing data set. So here we are taking 90% of values as the training data set and 20% of the value as the testing data set. So next, standardize the data. As like earlier, we used to do the normalization. Here we are calculating the mean value and the standard deviation value to standardize the input data. So here we are taking the values of the training data and we are creating the values like variables like X train and Y train. So LSTM architecture we are creating here. You can see the number of features is 1, number of responses is 1. And this LSTM layer is having 200 hidden units. So we are creating a layer named sequence input layer. So here we are mentioning the number of input features, LSTM layer with number of hidden units, fully connected layer of number of responses, then at last the regression layer. So in this you can see the training options. We are using the Adam optimizer. Max epochs is 20. See, even you can see for 20 iterations itself, our code took more time to execute. So we can increase this to 250 or 300, 500, anything we can modify here. Next, we need to train the network. So after training the network, we have to do the prediction. So after that, we are going to update the values also. So predict and update state. So the output will be net and wipe red. Then we need to plot the data value so that you can able to understand the observed value and the predicted value. So predicted values are nothing but here indicated as forecast. And at last, we have to plot the performance metrics of our project. So here you need to mention the error value, RMSE value. So those things are found as to calculate the performance metrics. So I will show the figures generated. So this is nothing but the plotting of the input data. X-axis denotes the month and Y-axis denotes the cases. So for each month, you can see how many cases are registered. And then the second image is nothing but the training process. So training process, here you can see the RMSC value and the loss value. So x-axis denotes the iterations. So in code, I have mentioned 20 iterations. That's why in x-axis, the values are between 0 to 20. So here you can see the epoch is 20 of 20. And the next here, just we are mentioning the observed and the forecast value. So these are the observed value and this is the predicted value. Now we are plotting that in a single subplot. Here you can able to understand the exact flow of the observed and the forecast data. And next one, RMSE value, root mean square error value. So this is for the another RMSE value, number of cases and the error. Here RMSE value is the 214.3629. Here RMSE value is 377.0332. So that's all about the coding explanation. If you have any doubt, you can mention in the comment section. Thank you for watching.